Today we're going to do our last lesson on proportional relationships, and your learning target, you can identify proportional relationships from a graph and table, and then also an equation. I did not put that on there. So that is your main learning target today. I'm going to give you an equation, and you're going to tell me if the equation represents directly proportional relationship or inversely, okay? So here's how. When you identify formulas, the first thing you want to do is get y alone. You want to know why? Because I'm going to show you. Notice directly is y equals something times x, right? We know that. And inversely, y equals something divided by x. Notice that with both equations, y is by itself on that side of the equal sign, okay? So y is all by itself on the left, y is all by itself on the left. So our goal when you're given an equation, you want to get y alone on the left and see which one it looks like. How you do that is algebra. Okay? We kind of did this a little bit, I feel like. Okay, so this first one, I want to know which one shows inverse variation. That means I want to know which one looks like this. Y equals something divided by x. That's what inverse looks like. So the first thing I do is I look to see is y by itself on any of these equations. No, y is with the 13.77 on the top one. On the bottom one, y is by itself. I'm just going to get it to the left. Okay, does that look like inverse? Does that look like y equals something divided by x? Yes, y equals something divided by x. That is the inversely proportional relationship. I didn't have to use algebra. Be nice to yourself if you don't have to use algebra, but you might have to. You just never know. Which equation shows direct? So direct means y equals something times x. Okay, so do I have y by itself anywhere that I can analyze it? The first one I don't, the x is by it. The second one I don't either because the 21.6 is by it. So I have to get y by itself on both of these. So the top one, what is by the x? Or not the x, what is by the y?
X.
The x. So this means y times x. How do you get rid of times? I divide. And then algebra says that what you do to one side, you have to do to the other. That cancels that out, and I get y equals negative 45.13 over x. Does that look like direct? No, because direct should be y equals something times x. This is inverse, isn't it? Okay, the next one. Y divided by 21.6. How do you get rid of divide? I'm going to times both sides by 21.6. Then that cancels that out. And I get y by itself like I want it to be equals, notice I'm going to put the number in front of the x. And it doesn't matter because multiplication is commutative. Does this look like y equals something times x? Sure does. That is the one. This one is the one. That's so messy. Let me just box out that equation. Ugh. I'm going to be okay. Okay, now the next one, example 3, I should number these. Which one shows inverse? So this is where you have to apply that. You know that inverse means something divided by x, and direct means something times x. So inverse should look like this. So I need to get y by itself and make sure x is on the bottom. Okay, the top one is y by itself. do I have to move? The negative 83, because that's on the same side of the equal sign. How do I move divide by negative 83? I multiply by negative 83 to both sides, because that's algebra. And I'm kind of going to do two things at once. Actually, I'm not, because I think that might confuse some people. So now I have negative 83x equals y, or y equals negative 83x. Flipping, because y is usually on the left-hand side. Does that look like y equals something divided by x? Nope, it looks like something times. That's direct. Okay, so now what's by the y on this one? How do I move times x? Divide to both sides, because that's algebra. That cancels this x out. Then I get y equals negative 74 over x. Okay, does this look like inverse? Yep, it sure does. Found it. That is the right one. Okay? And that is your learning target.